4.1.1, we have to evaluate the integral of x squared plus x, all divided by the square root of x minus 1 dx. In this integral, we have to let u equal x minus 1, and we differentiate u with respect to x. Differentiating x, we get 1. Differentiating negative 1, we get 0. So we multiply both sides by dx, so du will be equals to dx. And so we'll have our integral as our integral as x squared plus x over the square root of u. In the place of x minus 1, we substituted u, and dx is equals to du. So in the place of dx, we substitute u. So we are left with x squared plus x, which are in the form of x, and we want them to be in the form of u because we are integrating in the form of u. So we can try to, since we have u is equals to x minus 1, we take the 1 to the left and we will get u plus 1 is equals to x. So in the place of that x, we'll substitute u plus 1. So our integral will be equals to, so in the place of x, we substitute u plus 1 squared plus u plus 1. In the place of x, we substitute u plus 1, and in the place of x minus 1, we say that we'll substitute u du. So we expand u plus 1, and when we expand u plus 1, we will get u squared plus 2u plus 1 plus u plus 1 du over the square root of u. So we bring that down. So the integral of u squared plus that 2u plus that u, we get 3u, plus that 1, we get 2 over, so we choose to write the square root of u as u to the power 1 over 2 du. We know that a plus b plus c over d is equals to a over d plus b over d plus c over d. So in the same token, we'll get u squared divided by u to the power 1 over 2 plus 3u divided by u to the power 1 over 2 plus 2 divided by u to the power 1 over 2 du. So we take the u to the power 1 over 2 to our numerator, and we will get 2 minus 1 over 2 as our exponent, plus 3 to the power u 1 minus 1 over 2 plus 2 to the power u minus 1 over 2 du. From here, okay, let's 2 minus 1 over 2 is equals to 3 over 2 plus 3 to the power u 1 minus 1 over 2 is equals to 1 over 2 plus 2 multiplied by u to the power negative 1 over 2 du. So now we integrate. Integrating u to the power 3 over 2, we get u to the power 5 over 2 divided by 5 over 2 plus 3 multiplied by u to the power 1 over 2 plus 1, which is equals to 3 over 2 divided by 3 over 2 plus 2 multiplied by u to the power negative 1 plus 1 is equals to 1 over 2 divided by 1 over 2 plus c. So we can express the 5 over 2 as 2 over 5 multiplied by u to the power 5 over 2, and also expressing the denominator 3 over 2 as 2 over 3 multiplied by that 3 multiplied by u to the power 3 over 2 plus the 1 over 2 also can be expressed as 2 over 1 multiplied by 2 multiplied by u to the power 1 over 2 plus c. So that 3 will cancel out with that 3, and 2 multiplied by that 2 will be 4. From here, let's substitute. So we said that u is equals to x minus 1. So let's substitute x minus 1 where there is u. Plus 2 multiplied by x minus 1 to the power 3 over 2 plus 4 multiplied by x minus 1 to the power 1 over 2 plus c, and this will be our answer for 4.1.1. 4.1.2, we have to evaluate the integral of 20x cubed plus 2x squared plus 4x plus 15 all divided by 5x plus 3. So we use long division to evaluate this integral, where 20x cubed plus 2x squared plus 4x plus 15 will be long divided by 5x plus 3. 20x cubed divided by 5x is equals to 4x squared, and 4x squared multiplied by 5x is equals to 20x cubed. 4x squared multiplied by 3 is equals to 12x squared. From here we minus 20x cubed minus 20x cubed is equals to 0. 2x squared minus 12x squared is equals to negative 10x squared. We bring down that 4x. Negative 10x squared divided by 5x is equals to negative 2x. Negative 2x multiplied by 5x is equals to negative 10x squared. Negative 2x multiplied by positive 3 is equals to negative 6. Negative 10x squared minus 10x squared is equals to 0. 4x, this is 6, negative 6x. 4x minus 6x is equals to 10x. We bring down that 50. 10x divided by 5x is equals to 2. 2 multiplied by 5x is equals to 10x. 2 multiplied by 3 is equals to positive 6. From here, minus 10x minus 10x is equals to 0. 15 minus 9 is equals to 9. 16, damn it. 15 minus 6 is equals to 9. From here we take this 9. Since it doesn't have an x to pair it with, we divide it by the denominator. 5x plus 3, and our integral 4x squared minus 2x plus 2 plus 9 over 5x plus 3 dx. We integrate 4x squared. When we integrate 4x squared, we get 4x cubed over 3 minus integral of negative 2x is equals to negative 2x squared divided by 2. Integrating 2, we get 2x, and integrating 9 over 5x plus 3, we get 9 ln of 5x plus 3 plus c. And because of the chain rule, when we differentiate this, we also have to differentiate the inner function. When we differentiate 5x, we get 5, and we multiply it throughout, but in this case we are integrating, so we have to divide by 5 because of the chain rule. And this will be the answer for question 4.1.2. Question 4.1.3, we have to evaluate the integral of cos 4x multiplied by cos 3 over 2x dx. We know from our formula sheet that we have cos A multiplied by cos B, and it's equals to 1 over 2 cos of A plus B plus cos of A minus B. So we can express our integral in this form. So our integral will be equals to 1 over 2 in brackets cos of A plus B. A is 4x and B is 3 over 2x plus cos of A minus B, where A is 4x minus 3 over 2x dx 4x plus 3 over 2x is equals to 11 over 2x plus cos of 4x minus 3 over 2 is equals to 4x minus 3 over 2x is equals to 5 over 2x dx. From here we integrating cos, we get sine 11 over 2x, but because of the chain rule again, we have to divide by 11 over 2 plus integrating cos 5 over 2, we get sine of 5 over 2x, and because of the chain rule again, we have to divide by 5 over 2 plus c. This denominator 11 over 2 can be expressed as 2 over 11 multiplied by sine of 11 over 2x, and that denominator as well can be expressed as 2 over 5 sine of 5 over 2x plus c. We multiply inside our parenthesis with that 1 over 2, so we'll have 1 over 2 multiplied by 2 over 11 sine of 11 over 2x plus 1 over 2 multiplied by 2 over 5 sine of 5 over 2x plus c. That 2 cancels out with that 2, and that 2 cancels out with that 2, and we'll be left with 1 over 11 sine of 11 over 2x plus 1 over 5 sine of 5 over 2x plus c. Integration by parts, where we'll have 1 multiplied by ln of 7x dx. So the formula for integration by parts, we have integral of u multiplied by dv is equals to u multiplied by v minus the integral of v du, or the other formula where we get integral of f of x multiplied by g prime of x dx is equals to f of x multiplied by g of x minus the integral of g of x multiplied by f prime of x dx. We have to determine what our f of x is. If you're using this formula, if you're using that formula, you'll call it u, and also figure out what our g prime of x is if you're using this formula. But if you're using this formula, it's going to be called dv. So in this case, f of x between 1 and ln x. So remember that here we will differentiate the f of x, and here we will integrate the g prime of x to get g of x. So we cannot set ln 7x as g prime of x because we have to integrate it. So we are already looking for the integral, so we can't set g prime of x as ln x because we have to integrate it. So we can only set ln of 7x as f of x, and also set g prime of x as 1. We have to differentiate ln of 7x. So when we differentiate ln of 7x, we get 7x. Remember that the chain rule says that we also have to differentiate the inner function. So the inner function is 7x. When we differentiate 7x, what do we get? we get 7. We get 7, and when we integrate 1 with respect to x, we get x. So the integral of 1 multiplied by ln of 7x dx will be equals to f of x multiplied by g of x, f of x being ln of 7x and g of x being 7, minus the integral of g of x multiplied by f prime of x. So our g of x is x and our f of x is equals to, so that 7 will also cancel out with that 7 and we'll be left with 1 over x. So our f of x will be 1 over x dx. So that x will cancel out with that x and we'll be left with 1 here. Integrating 1, we get negative x plus c, and we get that as the answer for 4.1.4. 4.1.5, we have to evaluate the integral of cos squared in brackets x over pi dx. There are two methods that you can use to evaluate this integral. So the first method, so we have the identity cos squared a is equals to 1 over 2 plus 1 over 2 multiplied by cos of 2a. So our integral can be expressed as 1 over 2 plus 1 over 2 cos of 2 multiplied by our a dx, and when we integrate 1 over 2 we get 1 over 2x plus 1 over 2. When we integrate that cos we get sine of 2x over pi, and because of the chain rule we have to divide by 2 over pi plus c, and that denominator can be expressed as pi over 2 sine of 2x over pi plus c. 1 over that 2 multiplied by that 2 will be 4. So we'll have pi over 4, or we can use the formula sheet. On our formula sheet, given f of x as cos squared ax, and we are told that the integral of f of x dx is equals to x over 2 plus sine of 2ax over 4a plus c. So our integral x cos squared x over pi dx will be equals to x over 2 plus sine of 2 multiplied by a. Our a is 1 over pi x divided by 4 multiplied by 1 over pi plus c. So this 1 over pi can be expressed as pi over 1 sine of 2x over pi plus c, and this will be equals to x over 2 plus pi over 4 sine of 2x over pi plus c, and we have this as our answer for 4.1.5. 4.2, we have to evaluate the integral of 3x plus 5 all divided by x squared minus 6x plus 8, and we have to use partial fractions to evaluate this integral. So let's first try to factorize the denominator, x squared minus 6x plus 8. The factors of x squared, we have x and x. We take this sign, we put it here. The sign that we put here multiplied by this sign must give us that sign. So negative multiplied by negative is equals to positive. The factors of 8, we have 8 multiplied by 1 is equals to 8. We have 4 multiplied by 2 is equals to 8. So let's use 4 times 2 instead of 8 times 1. So the bigger number, we put it here, provided that there is no any other number before x squared. We take the bigger number, we put it here, and the other smaller number, we put it there. So if there was another number that side, so we are gonna approach it differently. So negative 4x, negative 4 multiplied by x is equals to negative 4x. X multiplied by negative 2 is equals to negative 2x. Negative 4x minus 2x is equals to negative 6x, and we have negative 6x as our middle term. So this is correct. So we'll have 3x plus 5 over x minus 4 divided by multiplied by x minus 2. This will be equals to a over x minus 4 plus b over x minus 2. We multiply both sides by our denominator here, x minus 4, x minus 2. So what we do on the left, we also do on the right. So we also multiply by x minus 4 on the right. That x minus 2 will cancel that x minus 2, and that x minus 4 will cancel that x minus 4. And on the left, we will be left with 3x plus 5. So we distribute the x minus 4 multiplied by x minus 2 inside our parentheses. X minus 2 will cancel out with that x minus 2. X minus 4 will cancel out with that x minus 4. And we'll be left with a into x minus 2 plus b into x minus 4. We let x equal any two numbers because we have two unknowns, a and b. So we have to be strategic about those numbers. You can let x equal any two numbers, but to make things easier, let's let x equals 2 and x equals 4, because we know that when we, so 3 multiplied by 2 is 6 plus 5. When we substitute 2 here, 2 minus 2 will be 0. 0 multiplied by a will be 0. So 2 minus 4 will be negative 2. So 6 plus 5 is equals to 11. We have negative 2b that side, so we divide both sides by negative 2. That -2 will cancel out that -2, and it will turn out that b will be equals to -11 over 2. From here, we let x equals 4. So this is our chief equation. We let x equal 4. 3 times 4 is equals to 12. 12 plus 5 is equals to 17. 4 minus 2 is equals to 2. We know that 4 minus 4 will be 0. That 0 multiplied by this, b will be 0. So our a will be 17 over 2. So we will have the integral of, so this integral, so if we have a, we said that a is 17 over 2, I mean, plus b, we said that b is equals to -11 over 2. So this integral will be the same as that. So let's integrate 17 over 2 over x minus 4 minus 11 over 2 divided by x minus 2 dx. We can rewrite our integral as 17 over 2 multiplied by 1 over x minus 4 minus 11 over 2 multiplied by 1 over x minus 2 dx. From here we integrate that, so we have 17 over 2 multiplied by the integral of 1 over x minus 4, which is ln of x minus 4, minus 11 over 2 multiplied by the integral of 1 over x minus 2, which is ln of x minus 2 plus c. And that's it for question 4.2 and question 4. If you have any questions, you can drop them in the comment section below.